I'm going to use this question as a vehicle to draw your attention to some very important concepts. In terms of tackling the question, the first thing I'm going to do is add to this diagram the information provided by the question. So it says OA is vector A and OB is described as the vector B. Now be careful to put your arrows on showing the directions. It further tells me M divides OA in the ratio 2 to 1. So OM is 2/3 of the vector A and MA is 1/3 of the vector A. Next it tells me that MN is parallel to OB. So here we have the first important concept. When vectors are parallel, they are a fixed multiple of each other. We know the vector OB is B, so any vector parallel to it is a multiple of this. And we'll call this unknown multiple of B K. Now I've got all the information given by the question, so I'm going to fill in the blanks. So here we have the second important concept. We define a vector in terms of where it starts and where it finishes. The particular route you take doesn't matter. I'm going to put in the vector AB. And note the route that I can take going against the direction A and along the direction B to give me the vector minus A plus B. Now for the third important concept, how to divide a vector by an unknown amount. I know N divides the vector AB, but I don't know in what ratio. AN could be a quarter, it could be a fifth, so we'll use the unknown variable lambda. So we can see here that AN is some unknown fraction of the entire vector minus A plus B. What's left over will be 1 minus lambda. For example, if AN was a quarter, then 1 minus a quarter would give us the 3/4 left over. So I've arrived at the situation where I've described every single vector on the diagram. I'll just remove some of the duplication for clarity. Now for the fourth concept, we're going to pick a particular start and end point and describe it using two different routes. In effect, we're forming simultaneous equations. There are a few choices, but it's crucial your route incorporates the unknown variables we're trying to find. However, in this case, part A of the question has asked me to describe ON in terms of A and B. And so it's this journey I'll describe using two different routes. The first route I'll take is this, giving A plus lambda minus A plus B. The second route I'll take is this. Could of course taken this route, but looking in particular at this vector involved, it just looks like it would be a bit of a pain. Now they both describe the same vector ON, so I can set them equal to each other. And I'll simplify this vector on the left by expanding out the brackets. Now this brings us to the final important concept. We can compare just the A vectors to each other and just the B vectors to each other. So if we look at A, we have 1 minus lambda A is equal to 2/3 A, and we can solve for lambda. So I'll subtract 2/3 from both sides and add lambda to both sides. giving me 1/3 is equal to lambda. And so we find that lambda is a third, and that does indeed split A, B in the ratio 1:2. As always, if this video has been useful, please give it a like.